Hi, now we comes to the application of electrolysis. Basically, we have three main application in the electrolysis, which is the first one is electroplating. Second one is a purification of metal, and the third one is extraction of metal. Electroplating is done to make metals look more attractive and resistant towards corrosion. For example, steel car bumpers are coated with chromium. Steel cans are coated with tin to make tins for food. Cheap metal jewelry is often coated with silver. To electroplate, a cathode will be the object to be electroplated. Anode will be the metal X, and electrolyte is a solution of a soluble compound of X. So let's take a look what it means by that. Diagram on the left shows the setup of apparatus for electroplating of steel jug. So the steel jug wants to be electroplated with silver. Therefore, silver metal will act as anode and are connected to the positive terminal of the battery, while the steel jug is connected to the negative terminal of the battery and act as a cathode. What happened at anode and cathode? At the anode, silver will dissolve by releasing electron and form silver ion. So here is the half equation. Okay, silver metal, okay, the silver electrode release electron to become silver ion Ag plus, while the silver ions will move to the cathode and discharge on the surface of the steel jug. So at the cathode, the silver ions will receive electron to become silver metal. Okay, the silver ions are attracted to the cathode. They receive electrons, forming a coat of silver on the jug. When the layer of silver is thick enough, the jug is removed. The rate of ionization of silver at the anode is the same as the rate of discharge of silver ions at the cathode. Therefore, the concentration of the silver ions in this solution remain unchanged. So can you explain the redox reaction that occur in the electroplating of metals? Yes, there is a redox reaction occur because oxidation reaction will always occur at anode and reduction reaction will always occur at cathode. Therefore, the oxidation and reduction occur simultaneously in one reaction. So for the electroplating sebenarnya you kena tahu barang yang nak di electroplate tu nak letak di mana. So benda yang kita nak electroplate kita akan letak di sebelah cathode, dan katakan kita nak electroplate dia guna silver. So silver metal tu kita letak di sebelah anode. Okay. Purification of metal. I want to highlight the words ductile and malleable here. So what is the difference between ductility and malleable? Actually, ductility is an ability of the metal to be stretched to become like wire without breaking, while malleability is the ability of the metal to be shaped. Okay, dibentuk. Ductile tu kita tarik tapi dia tak putus, tapi dia jadi macam wire yang panjang. But malleable tu maksudnya the ability of the metal to be shaped. Alright, so copper used in electrical wiring must have a 99.9% purity. The purity of copper extracted by the process of melting is about 99.5%. Even a slight difference in copper purity will negatively impact its conductivity. To determine whether a copper metal is pure, one must conduct the purification of metals through electrolysis. So, how does it look like? Okay, in the purification of metal, so kalau kita buat electrolysis, of course mesti ada yang jadi anode dan mesti ada yang jadi cathode. So in the case of purification of impure copper. So impure copper will connected to the anode, while a pure copper will connected to the cathode. Okay. The electrolyte is dilute copper to sulfate solution lah. Electrolyte ni kita gunakan compound yang ada elemen metal yang kita nak purify tu. Okay. What happened throughout the electrolysis? Okay. The pure copper here at anode will dissolve in the solution to become CO2+. Okay. And at the same time, the purities juga dia akan produce impurities. Okay. But the impurities does not dissolve. Therefore, the impurities tu dia akan sink to the bottom. Okay. The impurities is called sludge. Alright. What happened here? So the pure copper from anode here, dia akan oxidize by releasing electron to become CO2+ ion. And after that, this CO2+ ion will move to the cathode. Dia akan pergi ke sini and discharge by receiving electron. Okay, ada tulisan okay, by receiving electron to become copper metal. So at the end of the experiment, you can observe changes in the size of the electrode, anode and cathode. So impure copper tadi yang act as an anode tu dia semakin lama semakin menipis atau become smaller, while the cathode becomes bigger or thicker. So dekat cathode ni semua adalah pure metal. All the impurities, okay, selain daripada copper, dia akan sink to the bottom as a sludge here. Okay. Alright. You're supposed to be familiar with this word extraction because you have learned this during Form 3. Last year you dah belajar in the topic of metal. So extraction is an extracting a metal from its ore, and it depends on their reactivity. Basically kita ada two main method to extract metal. Tapi for the very unreactive metal like silver and gold, mereka sangat unreactive and they exist as an element. Okay. Dan tidak perlu to extract this unreactive metal like silver and gold, we does not have to undergo any chemical reaction. Kita hanya physically separate them. Okay. Kita separate sahaja metal from the sand secara physical. Okay. But the ore of all the other metals contain the metal as compound. These have to be reduced to give the metal. So untuk metal-metal yang lain selain daripada silver and gold must be extracted using a chemical reaction. Two main methods, okay, of extracting a metals, chemical reaction methods. The first one is electrolysis. The second one is reduction by carbon. Electrolysis method is for metals that are more reactive than carbon, while reduction by carbon is for metals that are less reactive than carbon. How we know that the metal is more reactive or less reactive? We must be based on the reactivity series of metal. Okay. Extraction of ore. We have extraction of aluminium, extraction of iron and extraction of zinc. Ore ni bermaksud compound lah. Yang compound yang ada metal tertentu. Okay. Okay. Extraction of metal must be based on the reactivity series, as you can see here. This is carbon. Okay. Any metals that are above carbon in the reactivity series, we consider it as a reactive metal, and method of extract this reactive metal must use electrolysis method. While any metal which is located below carbon in the reactivity series will be extracted using a reduction by carbon. So, kat sini extraction of aluminium. Where is aluminium? So aluminium is above carbon. Therefore, aluminium will be extracted using electrolysis process. Iron and zinc is located below carbon. Therefore, iron and zinc will be extracted using reduction by carbon method. But I just want to highlight the extraction of aluminium using electrolysis process, because this is the application of electrolysis, right? Okay, this is the cell for the extraction of aluminium. Okay, what we have here is a steel cell. Of course, the electrode used here is the inner electrode, which is carbon. Okay, carbon yang tengah-tengah ni will act as an anode, and then carbon yang di sebelah tepi ni, wall ni, dinding ni, dia bertindak sebagai cathode. Okay, alright, and electrolyte here is the molten aluminium oxide. Okay, our electrolyte is molten aluminium oxide. Mesti menggunakan molten aluminium, bukan aqueous. Boleh? Alright, so throughout the electrolysis nanti, okay, we will see a bubble of oxygen gas produced at anode, because in the molten aluminium oxide, the ion present is Al3+ and O2-. Therefore, O2- ataupun oxide ion will be attracted at anode here and discharged by releasing electron and produce oxygen gas. While O2-, right? Okay, aluminium ion Al3+ will be attracted at the cathode here and receive electron to become aluminium metal. Okay, in the same time, they will produce impurities that we call. So molten aluminium will produce and sink at the bottom because the density is higher. Okay, and after that dia akan keluar ikut sini lah. Okay, molten aluminium akan keluar ikut laluan ini. Right. There is cryolite here. So there is a function of cryolite. Okay, penting. Kenapa aluminium oxide must be mixed with the cryolite? Okay, because cryolite will reduce the melting point of the aluminium oxide. Therefore, less energy is needed. Okay, less energy is needed. So it is an advantage using cryolite. Okay, so reaction involved, we have two electrode, anode and cathode. Reaction involved at anode tadi adalah, okay, oxide ion O2- donates electron and undergoes the oxidation reaction and form oxygen molecule. The half equation is like O2- here release electron to become oxygen. Okay, so this is the balance equation, balance half equation. So because oxygen ada 2 kat sini, that's why kita tambah 2, integer 2 dekat depan oxide. Now the charge become 2 times 2- is equal to 4-. So kita nak balance dengan charge di sebelah kanan. So kita letak 4 lah elektron ni. So dia jadi balance neutral. Okay, so dekat cathode pula, aluminium 3+ will be attracted. Okay, aluminium ion is reduced by receiving electron and forms molten aluminium. So the half equation is Al3+ receive electron to become Al. So this is the balance half equation. Okay, aluminium ada 1 kan sebelah kanan. So sebelah kiri aluminium ni ada 1 jugalah. Cuma charge ni adalah 3+. So therefore, untuk kita neutralize the charge here, elektron kat sini pun kita letak 3. So cancel out jadi neutral lah. Okay. Alright, the compounds of the more reactive metals are very stable and need electrolysis to reduce them. This is a powerful method, but it costs a lot because it uses a lot of electricity. Okay, that's why tadi tu aluminium oxide tu dia mix dengan cryolite, okay, to reduce the energy needed. Okay. Alright, extraction of iron using reduction by carbon. Okay, yang ni you are very familiar with this one. This is what we call blast furnace, right? In the process of the reduction of iron oxide, okay, we must need an iron ore. Coke ini bukan air coke yang you minum ni. Coke ni adalah carbon source, and calcium carbonate as a catalyst. Alright, Okay. Alright, blast furnace ni saya tak nak terangkan sangat lah sebab kita dah belajar waktu Form 3. Awak kena tahu di setiap zon ni apa yang berlaku. Okay. Alright, cumanya, bolehlah kita revise sikit. Okay, hot air will be blown into the blast furnace. Okay, daripada bawah ni. Right, akan berlaku reaction di zone 1, zone 2 and zone 3. And then waste gas akan escape ke atas. And molten iron, because the density of the molten iron is higher as compared to the other materials in the blast furnace, so the molten iron will be sink at the bottom. So dia akan keluar di sini. Right? And the same time, it will produce a slag. Slag ni impurities lah. So impurities dia akan keluar ikut atas. Kadang-kadang soalan tanya, why the slag produce at the top of the molten iron? So jawapannya adalah because slag is less dense than the molten iron. Itu sahaja, okay? But again, you must know what reaction occur at each stage here. Okay. Alright, so ini dia summarizekan sahaja method of extraction from ore. For the metals is more reactive than carbon, dia akan gunakan electrolysis method. Less reactive than carbon, dia akan gunakan reduction by carbon. Alright. Quick review. Copper oxide is reduced to copper, which is then refined by electrolysis. Label the diagram of the apparatus which could be used to refine copper. Of course, kita kena ada anode and kita kena ada cathode. Macam mana you nak tahu anode and cathode? Kita tengok pada power supply. Positive terminal of the power supply means electrode yang connect pada dia adalah anode. While the negative terminal of the power supply, the electrode connector is a cathode. Okay. So for the purification of copper, okay, impure copper must act as anode. Okay, and pure copper will act as cathode. While kita gunakan dia dilute copper to sulfate solution as electrolyte. Next, okay, the chemical process taking place on the surface of the object is Cu2 plus 2 electron to become copper solid. Okay, yang ni So you want to steal the star object here. We want to coat the steel object here using a copper. Okay, so therefore copper akan bertindak sebagai anode and then steel object ni kita letak dia dekat cathode kan. So nampak kan ini? Right? Okay, I explain whether this process is oxidation or reduction. So based on the half equation here, I explain whether this process is oxidation or reduction. So kita ingat balik oil rig. Oil rig oxidation is loss of electron, reduction is gain of electron. So half equation ni menunjukkan dia gain electron. So this is a reduction reaction. Okay, I explain why the concentration of the copper ions in the electrolyte remains constant. Okay, reason. Okay, the concentration of copper ions in the electrolyte remain constant because the concentration of copper 2 ions remain the same. Okay, the rate of ionization of copper at the anode is the same as the rate of discharge copper 2 ions at the cathode. Maksudnya begini, Cu2 plus ion yang ada dalam electrolyte ni dia akan pergi ke steel object, pergi ke cathode and then discharge di situ. Kemudian dia akan diganti dengan copper anode yang dissolve sebagai Cu2 plus. So that's why dia punya concentration tidak berubah. Next. This is an extraction of aluminium. Aluminium is an important metal with a wide range of uses. Aluminium is obtained by the electrolysis of aluminum oxide dissolved in molten cryolite. Okay, macam biasa, this is anode, carbon. This is our cathode, okay, carbon cathode. Okay, dalam ni yang dash line ni indicates the molten mixture of aluminum oxide and cryolite. Alright, and at the end of the experiment, our aluminium will sink at the bottom. So kita dah extract dia akan sink dekat bawah lah. Alright, question number 1. Solid aluminium oxide is a poor conductor of electricity. It conducts either when molten or when dissolved in molten cryolite. Explain why. Senang saja. Bila cerita pasal conduct of electricity, dia mesti berkaitan dengan free moving ions ataupun free moving electrons. But in this case, okay, kita akan cerita pasal free moving ions lah. Okay. In solid, the ions are in lattice position, so no freely moving ions. When in molten state, the ions are free to move, thus it can conduct the electricity. You must always remember this about the conductor of electricity must be related to the freely moving ions and free moving electrons. But ions tu mesti ada dalam solution sahaja. Tapi kalau elektron, dia tak boleh berada dalam solution lah, dia mesti berada di luar solution. Okay. Why is the solution of aluminum oxide in molten cryolite used rather than molten aluminum oxide? So, tadi kenapa dicampurkan dalam molten cryolite? Macam saya dah bagi tahu tadi, function dia adalah to reduce the melting point. So, therefore, kita boleh reduce energy cost and better conductor when dissolved in cryolite. Okay. Ini salah satu contoh soalan lah yang berkaitan dengan application electrolysis. Okay, that's all. Thank you.